Okay, here we go. We are going to continue in Module 3, Topic 1, Lesson 4. This is Activity 1, Part 2 of it. I just realized in the last video I said Module 4, and it's not Module 4, it is Module 3. I'm going to have to put a note with that video. Okay, because I'm not redoing the whole thing. Consider the two expressions, 2x plus 5 and 2 times the quantity of x plus 5. So they want us to see if these expressions are equivalent by the three different ways. A table, a graph, and then using the distributive property to rewrite. Okay, so if we have the table for 2x plus 5, let's see what I can fit in the table here. So 2 times 0 plus 5 gives us 0 plus 5, so my answer here is 5. Now on this one, we have 2 times the quantity, we'll put a 0 plus 5. So this gives us 2 times 5, 0 plus 5 is 5. 2 times 5 is 10. So far they're not the same. Let's try for 2. So when x is 2, we have 2 times 2 plus 5. So 2 times 2 is 4 plus 5, and we get 9. Not looking good so far for them being equivalent. So we have 2 times 2 plus 5, which is the same as 2. 2 plus 5 is 7. 2 times 7. For this one, we then get 14. I'm going to switch to a different color just so it doesn't get all jumbled up in there. Okay, so then substituting in 4. So 2 times 4 plus 5. 2 times 4 is 8. So we have 8 plus 5. Waiting for it to get clear. There we go. 8 plus 5 is 13. So and on this one, we have 2 times, we're substituting in a 4 for the x. 4 plus 5. So we have 2 times 9, and we get 18. Okay, and then substituting a 5 in, we have 2 times 5 plus 5. That's a 5. So we'll have 10 plus 5, so we get a total of 15. And for here, we have 2 times the quantity of 5 plus 5. 5 plus 5 is 10. So 2 times 10 gives us 20. Okay. So from here, we would say, no, they are not equivalent expressions. Okay, so then it says, use the table of values to sketch the graph of both expressions on the coordinate plane. I would expect that we don't have the same line since we don't have the same output values. When we put an x in, we got these values kind of out, we say. When we put this x in, we got this value out for this expression. So use the square to represent the values from the first expression. So the first expression is this one. So our values for that are 0 and 5. I'll write those here. 0 and 5. 2 and 9. 4 and 13. And 5 and 15. Let me just write these ones at the same time here. So we have 0 and 10, 2 and 14, 4 and 18, and 5 and 20. Okay, so now we're going to plot these. Okay, So this might go out of the picture a little bit. You have yours written down, so I'm going to assume that you can see yours. I'm going to slide this up so that I can actually write. So the first one says 0, 5, and I'm going to do this here in green. These squares are in green. Use a square to represent the values from the first expression. So 0, 5 is my first point, so go over 0 and up 5, and I'm going to put a square. And then my next one was 2, 9, and then 4, 13. So go over to 2 and up to 9, and then 4, 13. Go over to 4 and up to 13. And then lastly for that one, it was 5 and 15. So I'm going to go over to 5 and up to 15. And when I connect those, it looks similar to this. Okay, and then it says to use a triangle for the values from the second expression. So we're going to start with 0, 10, then 2, 14. So 0, 10, over 0, up 10, I'm putting a triangle. Next was 2, 14, so over to 2, up to 14. Then we had 4, 18, and 5, 20. So over to 4 and up to 18. And over to 5 and up to 20. And then when we connect those, because we don't have the same line, we know that those expressions are not equivalent. So what does the graph tell you about the equivalence of the two expressions? So they are not equivalent since the graphs are two different lines. Okay, and then it says use the distributive property to rewrite the expression 2x plus 5. Okay, so when we're distributing, we're going to go 2 times the x, which gives us 2x, and then 2 times the 5, which gives us 10. So we have 2x plus 10. Are the two expressions equivalent? So this one is 2x plus 10. The first one was 2x plus 5. So what's different about them? So we know that it's no, they are not equivalent. So not equivalent. They're variables. They're variable terms. Right? That's a term. That's a term, a term, a term. Apart, 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 apart. Their variable terms are the same, but constants are different. Because this constant's a 5 and this one is a 10. Okay, you pause and get that written. I'll be right back.